All right, math leaguers, a couple of things. These are your midweek hints for week 3. Also, at the end of week 2, excuse me, when I did the wrap up, I didn't give you your joke. That's terrible. So I got to give you a joke now. That's kind of why we're all here, isn't it? So anyway, there's a cattle rancher who's got 48 cows on his ranch. And one day, the fence breaks and the cows escape, and he comes back from somewhere else and all the cows are gone. So he goes out and he hires a cowboy, and he says, "Hey, can you get on your horse? I'll pay you. Can you go and get my cows back and bring them back?" So the cowboy goes out, gets the cows, and brings them all back. And he says to the rancher, "The job is done. I brought back all 50 of your cows." And the cattle rancher says, "Well, that's great, but I only had 48 cows. And the cowboy says, "Well, yeah, you told me to go out there and round them up." All right, anyway, I told you the jokes are gonna get better every week. That one's pretty good, I think. It's still awful, but pretty good. All right, here's a couple of hints for week 3. I think number 6 is probably the hardest. There's an octagon that's inscribed in a circle, and it's asking for like what percent of this whole shape is outside of the octagon but inside of the circle. So basically like this shaded part. Now this is supposed to be all equal. All right, I can't draw. I'm doing the best I can here. But anyway, I tried to draw an octagon inside of a circle. It says it's a regular octagon, which means, different than what I drew, all these are the same length, okay? Definitely hard to draw an octagon. Also, I'm gonna give you a formula for the angles of a polygon. So, if you have a triangle, let's start off with a rectangle. A rectangle has 4 right angles. So a quadrilateral, a 4-sided figure, if you add up all of the sides, they add up to 360. Well, a triangle is half of a rectangle. So, all right, I'm not gonna restart this video. All of the angles add up to 360. For a triangle, it's half a rectangle. All the angles add up to 180. So for a triangle, 180. For a quadrilateral, all the angles are gonna add up to 360. You're like, what does this have to do with this? It's gonna help if we know some of the angles. For a 5-sided figure, like a pentagon, now this is not a regular pentagon, but think of it. It's a rectangle plus a triangle. Okay, so a 5-sided, a pentagon, they're all gonna add up to 540. All right, then if it's a regular shape where they're all the same, where everything's equal, so for example, if it was a regular pentagon, then what would be the measure of each angle? So something like this, still not a very good drawing, but you do 540 divided by 5, so these would all be 108-degree angles. Okay? 108. Okay. Now, once you know how to do that, there's a special formula. It's the number of sides minus 2 times 180. So for example, 3 minus 2 is 1 times 180 is 180. 4 minus 2 is 2 times 180 is 360. 5 minus 2 is 3 times 180 is 540. So now you can tell how to find the sum of all the measures of all the angles of an octagon. I'm not going to tell you what the measure of each angle is, but you should be able to figure that out. Now once you know the measure of that angle, you can also draw yourself a little triangle in there, okay? And if you know that this right here is a 90-degree angle, you should be able to figure out what this right here is in terms of the length of an angle, okay? And then, if you can figure out, I know this is really small, if you can figure out the length of this angle, you can also figure out the length of that angle, and then you know something about this triangle, and it actually showed up in last week's thing. If you know something about this triangle, you should be able to find the length of this side. That still doesn't do everything for you, but once you know the length of this side, then you know the length of all the sides. Remember, they're all supposed to be equal. Now, what I would suggest then is once you know the length of a side of the triangle, you can piece together the area of this octagon by making little shapes. Now, but wait a minute, I didn't give you any lengths of any size. That's okay, make something up. Just decide like, all right, if this is, you know, a certain length, then you would know what these two are. I know I'm being a little sketchy, but I'm trying not to give you too much information. Right? But it goes back to some of those special triangles that we learned in the last couple weeks. All right? And then, if you make up a length, you can also make up a length that would correspond, right, for the circle, all right, like a radius, and then you could figure out the area of the circle, and you could figure out the area of the octagon, and you could figure out how they compare. What percent of the area of the octagon is the whole area of the circle, and then whatever's left over is the stuff that's outside. I know, a little sketchy, but try not to give you the whole problem because it's a really fun problem. All right, number 9 I'm gonna give you a hint on. Just because it's a lot of wording and a lot of verbiage, but it's actually a really easy problem. So I'm not gonna take you too close to it, but you know, if it's a right triangle, there have been a lot of problems we've been doing that are Pythagorean theorem problems, and you know your special Pythagorean triples, or hopefully you're starting to learn them. You know, the 3, 4, 5, and all its multiples, like 6, 8, 10, the 5, 12, 13, all its multiples, all right, the 8, 15, 17, and so on and so on, okay? So you should know, start to get a feel for what those are, and then here's, I would think, the trick to knowing this problem. Again, I'm not gonna take you too far, but if you get a number and you square it, let's say 5. 5 squared plus 1 is 26. 5 squared minus 1 is 24. Okay, let's take another number, 7. 7 squared plus 1 is 50. 7 squared, 49, minus 1 is 48. Oh, if you take a value and you add 1 and subtract 1, these two values are going to be 2 apart, right? So now we're starting to look for triangles where 2 of the sides are 2 apart, and then it says that the perimeter of all the sides is 40. So again, I'm not trying to get you too close, but something plus something plus something equals 40. 2 of those somethings are 2 apart, and we can start to almost guess and check a little bit there. Okay, number 10, not really a hard problem. I left out a word in the on the sheet, or we left out a word on the sheet. But anyway, the gist behind it is that Hannah was traveling along. Let's see, how fast was Hannah traveling? This was starting at noon, okay? Hannah is driving due east on Vinculum Road at 40 miles per hour. Now, I had Hannah moving prior to that because I didn't want somebody to think, well, she doesn't, because when you start at noon, you don't just start going 40 miles per hour, right? Like you have to build up speed. So what I was trying to get at was that she was already going 40. And so she was going a constant speed, 40, the rest of the way. And then Warren started much later, okay? And he hit this exact same point at 2 p.m. But Warren was going faster. Warren was going 60. So I drew like 3 arrows, right? Like Warren's going faster. So he's trying to catch up. So the question is, when did Warren catch up? Well, I'm not gonna take you too far, but just think about, where's Hannah at 2 p.m.? When Warren's here, where's Hannah? Hannah's 80 miles down the road. You can almost guess and check this thing, right? At 3 p.m., where's Hannah? Where's Warren? At 4 p.m., where's Hannah? Where's Warren? Okay? So there's an algebraic way to do it. It's a lot easier to do it without algebra. And finally, number 18. Again, this one's also, I think, pretty easy. Let's see. It says the ratio of boys to girls to coaches at a basketball camp is 5 to 3 to 2 respectively. What that means is in that order, boys to girls to coaches. Now I made up a similar problem, but with different numbers. So I would say something like the ratio of boys to girls to monkeys in a room is 4 to 5 to 2 respectively, okay? Meaning boys 4, girls 5, monkeys 2. There are 77 living things in that room. Well, how do you do this problem? Again, there's like an algebra way, but really what you think about it is they're in little groups, right? They're in little groups of 11. 4 boys, 5 girls, 2 monkeys. That's 11 living things. Now, if there's 77 living things altogether, there's 7 little groups, little subgroups of 11 things, okay? Well, if there's 7 groups, and I said, well, how many girls are there in total? Well, if there's 7 groups, every group has 5 girls, there would be 35 girls. Hopefully that makes sense. All right, again, I'm not going to take you too far and do the actual problem, but that's a very, very similar problem and a really quick, easy way to do it. All right, hope you have a great week. I have a kind of a weird midweek task to do a little artwork, and then we're actually going to judge your artwork really quickly. We're not going to sit there and come up with a rubric, but you're going to draw a house on this program if you care to do it. There's lots of ways to do it. You can draw it by plotting points. You can draw it by knowing the equations to certain things. But anyway, that'll be in your email coming to you. All right, have a great week.